Hello, DDP students. In the last tutorial, we learned what tolerance is, why it's used in manufacturing, what the three types of tolerances are, limit dimension, unilateral, and bilateral, and how to find a tolerance when there isn't one already on a dimension. This tutorial is going to be about what we're going to be doing in class. So this is the Google Classroom lesson here. And if we scroll down, we have the attachments. The classwork can be found in this PLTW assignment, tolerate this. If we scroll down, our classwork is going to be based on this blue conduit bracket. We have A, B, C, D, and E. One thing I want to point out is if we look at this, okay, if we were to look at this here, this letter B, we have a counter bore right here, the diameter of a counter bore, and we have the depth. So this is going to be the tolerances on this hole here. So you'll notice that there is a tolerance on both the counter bore and a tolerance on the depth. So B is going to have two tolerances that we're going to be looking at. The second thing that we're going to be looking at is this second blueprint of an axle stabilizer. We have the F, G, and H. So let's take a look at what we're actually going to be doing. If we look at the attachment called tolerance tables, we have these conduit brackets here. And we have this table, okay? And the table is A, B, C, D, and E. We have the letter that corresponds to the blueprint. So A is going to correspond to this A, B is going to correspond with this. We're going to write the type of tolerance. Is it a limit dimension? Is it bilateral? Is it unilateral? We're then going to write out the explanation of what the tolerance is, why it is, okay? So the written expression for A, if we were to take a look at A here, we have this tolerance here, okay? And it's all of this is going to have to do with this hole, all right? So that's for both A and B have to do with that hole. So a written explanation would be the diameter of the through hole may be as much as 0.001 larger or 0.001 smaller than the 1.138 inch diameter. So what I want you to write is how much larger and smaller it's going to be than the original dimension. So I want the feature in there, whether it's a hole, what kind of hole, is it a counter bore, is it a through hole, how much larger is it going to be, how much smaller is it going to be, and the original dimension that it's supposed to be. All of that information should be in the written explanation. The total tolerance here is going to be what that total tolerance is. So in this case, it would be 0.002, okay? Another example of a written explanation is, and this is for B, the counter bore hole diameter can be as much as 0.001 inch larger or smaller than the specified 0.250 inch diameter. Similarly, the depth of the counter bore hole, remember that B has both a tolerance for the diameter of the counter bore and a tolerance for the depth of the hole. The depth of the counter bore hole can be as much as 0.001 larger or smaller than the 0.163 inch. So all of this information is telling us what the original dimension is, how much larger it can be, how much smaller it can be, and the feature we're looking at. So in this case, it's a counter bore hole and the depth. So we want all that information in there. And again, the type of tolerance. So we have the letter, the type, unilateral, bilateral, or limit, the written explanation, and the total tolerance here. So we're going to be doing that for this as well. We have FGH, and that is all we're going to be doing for part one. So let's take a look at the second part of our work. We're going to be creating this tower right here, okay? It's very easy to make. This tower will take about 5 minutes to make. And once it's done, we're going to pull out the dimensions just like it is in the tutorial. So that is the first step. The second step is we're going to watch a second tutorial. Let's just close this out here. And this is going to show us how to actually apply tolerances to the dimensions that we pull out from here. So if we take a look at this, I'm going to fast forward it so we can see what that looks like. Okay. As you can see, we have the tolerances on there. Okay. So what I'm going to be looking for is a screenshot of just the assembly drawing with these same views and the tolerances applied to the dimensions. That's it. So for deliverable 1, you can just take that whole attachment, fill it in. It's a Word document, so you can write right on it. Then you can upload that to your engineer's notebook. So we want the completed tolerance tables in your engineer's notebook. For part 2, I just want to see an assembly drawing with the same views and the tolerances on the dimensions, same as it is in the video. That's all we're going to be doing for the classwork. If you have any questions, you can email me or talk to me in class. And thank you very much. That is all for the tolerance classwork.